Thank you. Hello, thank you for all coming to my talk. I'm very glad to be here today to present Kùzu, a graph database management system for Python graph data science. And my name is Guodong. I am currently a co-founder at Kùzu Inc., which is a startup company around Kùzu. And prior to that, I was a postdoc at the University of Waterloo. And that's also where Kùzu started as a research project. And now it is open source, and we are actually committed to building the community around it with the goal of making it as a system that you can easily use for graph data science in the Python world. So by looking at the title, I guess like many of you have some doubts like already in your mind, like why graphs, like why not tables, why not documents, extra? And the reason is actually simple to me, and I believe that graph is one of the most nature, the structures or representations that you can find to represent your application data. And with graphs, we can abstract, the beauty of it is we can abstract data into entities and relationships between them and view them in an object-oriented way. And I'm going to show you like how this can bring us some benefits. So the first benefit is that we can do beyond relational modeling and computations. So these are things that normally you are not able or you are not intuitive to do if you model data as tables. For example, it will be more nature to think of your data as to think of paths between entities inside graphs instead of like modeling them over a bunch of tables. Also, there are also some like semi-structured data, like very heterogeneous knowledge graph that is very hard or not easy to find a good tabular representation. And secondly, graph can also make it more intuitive to express your queries, find patterns. Like example is finding cycles across entities, which are like quite popular in some applications such as fraud or risk detection. So Kùzu, like other graph database systems, are built with those benefits into consideration. And Kùzu comes with the labeled property graph data model, which is a popularly adopted model. And we also adopt a high-level query language called Cypher, which is similar to SQL in many ways. And I want to show you one example how the graph model combined with the query language can make certain things easier. And those are things you don't really want to do them over tables. So here is an example of finding recursive patterns. So the query is that we want to find or direct or indirect possible sources of money flow into Alice's account from Canada. And if you think of this as tables is going to be expressed in SQL as recursive recursivity is, and you will start your query like with recursive. And I'm not going to show the actual query here to simplify my presentation, but I encourage you to give a try to feel the difference. And now if you say what's presented here as a cipher, so you just need to simply append a star after your edge label, which is transfer in this query. And so you can feel the difference, like how easy it is to express a recursive pattern with Cypher and with a graph model. And another query I want to show is that, so let's make this a little bit even harder. Like we want to find the shortest path of money that flows into Alice's account from Canada. And so now I don't really even want to try to write this in with SQL. But again, if you look at the query here that's written in Cypher, you can find that still it's quite easy to express it. You just need to append a shortest keyword after the recursive pattern. So that is just one example of how graph modeling combined with the query language can make things easier, especially when you want to express your recursive patterns, or like there are so many cases like you want to find unions or patterns, or you want to query your schema information together with your actual data, or like you get some data that's semi-structured and you can take the flexibility of graphs to make it easier to model. So I'm not going to go into all of the details on this here, but we actually have a nicely put blog post on our website. So I put the link on the right bottom part, and you can actually find all the details if you're interested. And besides the ease of modeling and pattern finding, and Kùzu as a system specifically has some other benefits. And one is that Kùzu is actually an embedded system, so it makes it easier to be integrated into your data science pipelines. And so compared to the traditional server client mode, you need to maintain a separate server, you need to deal with your config files, you may also need to set up your access controls, but that's just simply for the case that maybe you just want to do a quick overview or exploring over your local data, and you don't want to bother with all of those efforts. And instead, like Kùzu is embedded and it's easy to install, and you can just simply pipe install it, and inside your Python notebook or your Python script, you can get started to use it without all of those settings. And also Kùzu can make use of the zero copy benefits inside the same process without transferring your data between server and client. So besides that, Kùzu is a system that's with a kernel especially optimized for graph workloads. And I want to highlight one example why Kùzu is good for is fast in terms of finding patterns. So one common thing that's in graph workloads is that you typically would get growing curve, like you would get some patterns that your query result is going to be exponentially growing. And so if you take a look at the graph on the left bottom corner, so we have a bunch of A's, a bunch of B's, and a bunch of C's. And each B is actually quite densely connected, which around 100 A's and around 100 C's. And we have a query that's very simple. We want to find all the connected A's and C's to one B node, which is least in this case. So traditionally, in almost every database system, the size of the intermediate result, which is a common way to in database system measure the complexity of the query, will actually grow exponentially to a square of 100. While in Kùzu, we can come up with a way that compress the query result in a very syntax way to reduce the size to be linear growing instead of exponentially growing. And this can greatly boost our query performance. So this is one high-level overview of Kùzu's internal architecture to make pattern finding faster. Also, Kùzu comes with other state-of-the-art solutions that we understand, like vectorized execution, column storage, and predefined point-based joins, and some novel join algorithms for certain patterns. And I'm not going to discuss this details here again, so for simplicity. But you can find the details and pointers to our research work from our blog post or from our paper on the conference this year. And to summarize a little bit here, so what Kùzu is a graph database system in the first place, but more specifically, Kùzu is an in-process analytic graph database system that's optimized for graph data science in the Python world. And if you're aware of SQLite or DuckDB, you can interpret Kùzu as a SQLite DuckDB for graphs. And as an embedded system, we can take the advantage of zero copy when possible. And another dimension to different Kùzu from other system libraries that we actually aim to be a high scalable one that's on as a single node system. So it is disk-based, and it is also optimized for multiple parallelism. And some of the techniques are based on our research works and our understandings of the state-of-the-art techniques. So lastly, Kùzu is free, and it is open source with MIT license. So you can give it a try and do anything you want on top of it. And it's also easy to install as a Python library. Just do a pip install Kùzu. And in a very high-level view, Kùzu actually aims for two things for graph data science in the Python world. So the first thing is that we aim to make it easy for you to ingest your data and model it as graphs, and also exchange your graph between different file formats, between different libraries, and even between different systems. So for now, what we support is that you can ingest data from CSV files, PyQuick files, and also from pandas data frames. And also Kùzu can export data to NetworkX, to pandas, NumPy, and to Arrow. And also we have some tight integration with PyG for your graph learning pipelines. And you can also use Kùzu as the PyG remote backend, which is a quite advanced feature, allow you to train your graph when your graph doesn't fit in memory. And another thing to note is that these libraries and things and system supported by Kùzu is not just graph ones, but also graph ones and also with typed ones. So Kùzu can actually bridge gaps between these two models. And so there are more integrations that's coming, and showing in the figure is kind of like a vision we aim to support. And we also plan to support defining graph schema inside Kùzu or your relational systems like Postgres. So you can let us know if you got interested in these features. And technically, what Kùzu aims is to make the integration, cleaning, and transform and extracting all of the graphs easier using the high-level query language and also quite powerful kernel. And the example might be like this. So you got you have ingested your data from various sources, and then you extract your subgraph out. You might do some graph visualization and run some graph algorithm through NetworkX, or you would run some graph learning pipelines through PyG and then feed your result back to Kùzu through pandas. And you can also export the data to your relational pipelines through Arrow. So I want to give a quick two demos. So one is that how we can use Kùzu. So first basic operations in Kùzu, that how you can define a graph schema, which consists of node and relational tables, and how you can load those data into the database, and how we give a demo on how we can integrate that with NetworkX for visualizations, and also to make use of NetworkX to do some graph algorithm, and also how we can ingest data from pandas and also export queries out pandas. So we would be using a very popular dataset, but it's also a very simple one. So the schema is called movie length, and the schema is consisting of 4 tables: 2 node table, user and movie, and 2 relation table, text and race. And we would use race mostly in this demo. And we use a small version of the dataset just to make things go quicker for the demo, simplistic demo. And so let's get started by installing Kùzu and NetworkX here. And we're also going to import some libraries for demo and cleaning up the database directory and download some CSV files. Yeah, just wait. And let me see if we got some questions. So is Kùzu a native GraphDB? Yes, so Kùzu is a native GraphDB, and we have our own data storage. We don't support encryption, and so if you mean like you are accessing Kùzu in RESTful way, so we actually don't support that. Yeah, but we are native, and we have our own data storage and our own query processor. Can you run any node to vector on Kùzu? Oh. Can I show this? So you can't directly run node2vector inside Kùzu, but you can definitely export the node features outside Kùzu to whatever library you want to use and run node2vector on that. And we support the vector data type, which is called fixed list in Kùzu, and you can easily ingest them back inside Kùzu. And let's get back to our demo for a while, and I will get back to Q&A. Yeah, so we have done the install and the import. Let's simply download some CSV files. And the first step is in the demo is we need to first create a Kùzu database object, and as Kùzu is actually on disk system, so we need to pass a local directory path that will hold all of the database files and also create a connection. So simply done as here. And the first step I want to explain that when you want to load data into Kùzu, that we first need to define a set of nodes and directory relations, and through some create node table, create read table statements, and these are quite similar to say called create table. For example, the create node, we would define some properties and also specify a primary key, which will store as the unique identifier for each node. And also for create real, that we are defining from which node table to another node table, and you can also define the properties. And so let's do this. So after defining the schema, now we can start loading the data from our CSV files. Just simply we use the simplest way to use copy, and this is good for the backloading. And the first way, before we go to more, first let's visualize the graph a little bit. So I want to just show the ability that you can run a query that's returning all of the nodes and rails, but we don't want to export all of them. That's going to slow the visualization in NetworkX. But so I just limit 300 rails here, and we can say how they look inside the NetworkX. Simply visualization. Now we get some graph that you'll find that okay, some user has rated lots of movies. The red is user and the blue one is a movie. And next, I want to demo that how you can actually combine Kùzu with NetworkX to do more complicated things. You can use NetworkX for graph algorithm, and you can use Kùzu for your pattern findings. And the case is that we want to recommend movies to users by just finding some other users who share similar tastes, and also those movies are highly rated by those users who share the same taste. And we want to do that, we first create a new relationship table, similar taste between users, and so that then we can extract a pair of users who have rated the. So basically, the definition is to extract a pair of users who have rated the same movie, and they're kind of recent, let's say after 2015, and with quite high scores, let's say larger or equal than 4.8, and create a relationship between them. So you can simply do that. We first create a real table, and then we define some patterns. The first is from U1 to a movie that was rated by U1, and we have another pattern that's from U2 to the same movie. So we find the users who has rated the same movie, and we put some filters on ratings on the year of the movie. And also, of course, we don't want to find the user that becoming self-loop between them. So we can use the create statement to create new relationships between each pair of users, and so that can be simply easily done. And after the extraction, let's say how the new relationship looks like. Okay, I don't know why, but my laptop is getting a little bit Okay. Yeah. So from the graph, we can say that actually there are some visible clusters of the users in the graph that they tend to share similar tastes more than compared to others. And now an idea comes to us that we can just do one step further, that we decide to perform some community detection in NetworkX and then use that to further to polish the recommendation. And we just choose to use a classic one that's called Gorman-Newman community detection algorithm from a list of community detection algorithms provided by NetworkX. So yeah, so this is similar to the previous code block that we export the relationship to NetworkX and call the Gorman-Newman to do the community detection. And I'm going to omit the code that's performing the validation of the results. So they are just slightly modified from the example provided by Network's official website. And let's give a run. And we can say from the graph here, we got 5 communities, and some are large and some are quite small, like with only one user. And we can also convert the result of community detection from NetworkX into a data frame with 2 columns. One is the user ID, and the other one is the community ID that the user is in. And print the data frame, we can say that we got lots of users in the community 1, and some, quite a few in 2, and yeah, much less in 3, 4, 5. And now we can do, what we can do is that we can export this result back to Kùzu by out our user table to add a new property called community. And through the rate pandas core, we can integrate them and update the community value with the one that's found by the community detection algorithm. Give a run. And finally, let's say we want to make a recommendation for some user, well, say the user with ID 15. And what we can do is that we can find the recent movies that after 2015 that the users in the same community with user 15, and movies that those users have highly rated. Say like the rating is larger or equal to 4.8, and but not yet rated by user 15, right? So we don't want to recommend movies that the user has watched already. And also we can order the returned titles by their highest rating and export the query result to pandas and print the result out. So what we do here is that we first find the movies that's rated by user 15 and collect them into a list, movies you want. And then we express another pattern that's to find users that within the same community with user 15, but it's not user 15, of course. And then with the last pattern is that we find that users who have done highly rated, find the highly rated movies by user 2, and the movies are recent, and also those movies are not rated, haven't rated by user 1, and we return the result and order by them by their highest rating. So we got a bunch of movies that we can recommend now, and they are sorted in by the highest rated order. Okay, so that's the first demo. I think I still got some time. Let me back to the Q&A. So how does Kùzu compare with commercial graph databases such as NumFOCUS and GDB? So first of all, we are actually open source, like NumFOCUS also has open source projects, but we are committed to building the open source community, and Kùzu is actually embedded, so it's not server client mode. That's something we intended to we choose to do is because we want to be highly integrated with the Python ecosystem, data science ecosystem. And for the integration with GNN, right now we have integration with PyG. So, but you cannot do GNN, train GNN inside Kùzu, but you can very easily export your query result outside to PyG and perform the trainings. And we actually have two examples that to collab that show how you can do node property detection, prediction, or like link prediction, combined Kùzu with PyG. Hope that answers your question. Yeah, or any roadmap on AI models. So we are definitely looking at the vector combination, vector third vector index with graph, but that's not, we don't have things. Yeah, we don't have features that will be that's public yet. So machine learning or AI models, we don't support models directly inside Kùzu, but so one thing is that we might be able to add support extensions that you can define some submodules that can run or that can run inside Kùzu, but we don't aim to, right now we don't aim to do everything inside Kùzu. So we want to be the one that can easily integrate everyone, that can, like you can find the best library for each task for you, but you can exchange data very easily between them through Kùzu. Yeah, sure. I will share the notebook and I will update them in our website, so you can have that. Yeah, so let me quickly show another demo that we also have a web explorer that's a browser-based user interface. So you can visualize your query results. You can you can also define your schema in a visualized way. And this is also an open source project under the Kùzu organization in GitHub. And so it can be used in several ways. One is that you can start a explorer, like is a Docker image. So pointing to an existing database locally you have, or you can just start with an empty one and play around with it. So for simplicity, I just start with an empty one, and so this is the interface. So we have a shell that you can issue queries, and then we have some data sets that you can pre-built this set you can load. So I have loaded the Kùzu demo here, and then you can see the schema. So I just want to quickly demo first how the query visualization works. So I will just write a very simple query that you can extract the whole graph and visualize them. And this is the visualized result. And in the right side, there is a side panel that you can actually see the properties of each node and where. And also the query result comes with Tableau view and also JSON view. And if you provide as your ChatGPT key inside the settings, so I don't want to show that. So you can also issue queries with natural language. For example, I want to say how many users do we have in the database. and it would generate the corresponding Cypher queries for you, and you can actually view and make edits on the generated Cypher query and also the query result. So let's try something else. So since we are in Waterloo, let's see how many users are located in Waterloo. Yeah, so you would get a more complicated query as written by GPT. So as for schema, you can make change, edit your schemas in the schema panel, and say we can add new node. Director. Name be string.
Hi, Guodong.
So now,
we're actually over time right now. If you want.
Oh, sorry for that. Yeah, so that's it, and we also have it on our demo website. And thank you. That's all.